Hello. So we're going to be doing a financial fraud detection system and financial fraud detection system using machine learning uh, is a part of a data analysis project, and we will be starting now. We will take we will take the credit card data set from Kaggle. This is the data set we have downloaded from Kaggle, and coming to the project that has been done in Google Colab. So we'll be importing pandas, NumPy, Matplotlib, and Seaborn. These are basic things that we do, and all these things I will be explaining as we go on further. So first we need to import the dataset into the project. So I will be copying the path and will be pasting it here. So make sure you run everything every time so there's no errors at the end. So that's done. Run this. Okay, good. So now this command df.head is to give us an idea of what the dataset looks like for the first five rows. You can see there's many vectors and a time column, an amount, and a class column. So I've done this as well uh, for cleaner viewing. There's a time row, there's 28 vectors and an amount and a class row as well. So this time row is of no use, so we will drop it. Uh, so what the in place does is it does not create a new dataset. It just makes the changes in the existing dataset. So let's check the type of datasets that we have using df.dtypes. We need to do this because we are going to perform executions based on machine learning models, and machine learning models only work on numerical data. And looking at this, we only have float and integers, so that is good. So now we need to check for null values. uh, so I'm using df.isna. The sum is to uh, amount. The sum is to give the total number of null values. Let's run this as well. uh, there are no null values. Good. So we must understand the pattern. So all this we're doing is just because we need to get an idea uh, of how much there are valid transactions and how many fraud transactions are there. So to understand the pattern, and it is given within the data set that if the class is 1, it is a fraud transaction, and the class is 0 is a true transaction. But there are many transactions like 2 lakh 46, 2,86,000 some transactions. So what we will do is the 2,46, 86,000 transactions of valid transactions, and a very minute number of fraud transactions because fraud doesn't happen very often. And I will show you that as well because I'm using a matplotlib to give you an idea of the fraud transactions in comparison to valid transactions. um, I'm using ggplot. The size doesn't matter. It's a distribution of class because the amount, and as you can see, let me run this as well because as you can see all these spikes huge spikes around for transactions, whereas the thing, you can see the distribution in the amount class. All these spikes are the fraud payments. So let's go distribution of classes pro in comparison to the valid transactions compared to the fraud transactions. Fraud transactions are very minimal, and so you're using a standard scaler because the values in the amount row is very diabolical, because all the things in the amount column, let me show you here. As you can see, the standard deviation is 244. That itself is an indication that there are many variations in the values in the amount column. So we will be standard fitting. So you will be scaling and optimizing those using a standard scaler in between the values of -1 to 1. We will run it, and this is the values from -1 to 1. Very good. Now we need to drop the duplicates using data.drop duplicates, and in place is equal to true. In place, what in place does is it doesn't create a new data set, it just makes these changes to the existing data set. And now coming to the train test split. Why we need train test split? Because train test split is needed to use one against the other to compare and test the data. So we will be creating X train, X test, Y train, and Y test, and we will be splitting 80% for the training size and 20% of the data set for testing size. Now coming to the logistic regression model, these we will be testing it over a few models: logistic regression, random forest classifier, XGBoost model, to check which gives the highest accuracy and F1 score, and then train our dataset on the best model in the end. So we will be fitting X train and Y train, and we will be predicting the values against X test, and we will be finding the accuracy and F1 score as well. And we will be using X test and Y test for the accuracy, and Y test and Y prediction, because we will be using the predicted value from the logistic regression in the F1 score for this current model. How much is the accuracy? Great. We need to run this logistic regression model first. 99.87. Now how much is the F1 score? 0.78. Okay, very good. 99 is very very good, because of all the pre-processing and data cleaning we've done. As we said, in this random forest classifier takes a humongous amount of time, so I've already run it. The accuracy of the model is 99.94, which is really great. F1 score of the model is 0.89, which is also great. XGBoost model, again, in XGBoost model, like in any other model, we will train. We will fit X train and Y train, and we will predict it against X test. Let's run XGBoost model. Run it, and we will do the same with the accuracy. 99.87, really great. One score of the model 0.8, which is also good, but you have to remember we don't get the exact values every time we run it. And I have run all these three models many times, and every time XGBoost model gives us a good accuracy and F1 score. So we'll be using XGBoost model as our model to train. We will train using this model, and we will predict if a transaction is fraudulent transaction or it's a valid transaction. So we will be using Smoot. I have no idea, I've just learned about it. Not even learn, I'm just using it, but I don't know use cases of it. So we'll be importing Smart. And I forgot to tell you, that we have imported all those libraries from scikit-learn to the metrics. See, scikit-learn.linear model for logistic regression, from ensemble, random cross classifier, XGBoost for a XGBoost classifier from XGBoost, and the metrics for F1 score, um, accuracy as well for the standard scaling for pre-processing, and the model selection for using train test bed as well. Everything you need to import for all the libraries to be used in the end. And you can for more accuracy or for more depiction purposes, you can also use ROC AOC curve to see which model gives the higher accuracy. As I was saying, we're using Smart. We will be using X-res and Y-res Smart to fit the resample value data from X, Y. It's just the value counts, not necessary. So we will be training similarly as we've done in previous models as well. So we will be using XGBoost classifier because it's the best model that we've done, and we will be training the data on this model. So we'll be hitting xtrain and xtest against xtrain and ytrain against xtest. So we'll run this as well. So let's see how the accuracy has changed. 98.48, really good. What's the F1 score? 0.98, excellent. So we will fit X-res and Y-res, the resampled data in XGBoost, and we will wait. It's done. Now we will be using JobLab. It is used for the final prediction in the final prediction in this project, to predict if it's a fraudulent transaction or it's a valid transaction. So import JobLab, and then we will dump all the data in the XGBoost classifier. So it will create a pickle file. I don't know what exactly a pickle file is, but I just learned it recently, and we will do this as well. Record pickle files created, and it will be reflected in here. You can see it's reflected here. And for model, we will load the data set from this into the model object. We've done it. Now this is the final part. JobLab.load, same data frame. If you take any values from this credit card.csv data sheet, and we had 28 vectors, so if you place all the values in 28 vectors and the amount, it will predict the class which is 0 1 is fraudulent, and else it is a valid transaction. I did check in the datasheet, it was indeed a valid transaction. Let's run it, and after running you can see it is a valid transaction. So that's it. We can predict any kind of transaction, if it's a fraudulent transaction or valid transaction, using this model. So thank you. That will be it from my side. Thank you again.